In this video, we're going to go over how to write the code to control this lead screw. So you can see they have a drawer, have a little piece of weather stripping here. There's a M5 lead screw, and on the back we have a linear potentiometer, so we'll be getting the voltage off that. There's a little tab from the potentiometer that fits into the lower jaw here. And so if we look at the code, let's see, you have the different include statements. We're going to use a button to start it, and for the analog potentiometer, we're going to use pin 18. I think that's actually analog A0. And so these numbers right here, the way that we control the servo with the 32U4 is we're going to tell it the length of the pulse in microseconds. So by default, the range of the pulse goes from 1,000 microseconds to 2,000. And so 1,500, you can see I have it set to 1490 here. So you might have to tweak it a little bit to get and this is where the motor would be stopped. And then at 1,000, a value of 1,000, it would be full speed in one direction, and 2,000 would be full speed in another direction with this continuous rotation servo. So you can see that have it say it's around 1,500 is stopped, so 1,300 is like around 200 less than 1,500, so that will put the motor in one direction, and then 1,700 is 200 in the other direction from 1,500, so that has it turn in the other direction. And I've set up this timer with a 500 millisecond delay so that we're not just going to print every half second basically. And then you're going to have to figure out, in other words, just move the jaw to different positions and figure out what the voltage or the analog to digital converter. Remember, for the 32U4, it has a 10-bit analog to digital converter, so it's taking 0 to 5 volts and converting that into a number between 0 and 1023. All right, so if the jaw, and again, you can just move the motor, have the motor go to different positions, and figure out what these numbers should be. So I'm just arbitrarily picking 600. That's I want to open up the jaw to some value, so I have 600, and then the 940 is a little more important because that's when the jaw is going to be closed on the plate, right? So we have this plate that we're going to be picking up, and we want to figure out what the voltage should be on the potentiometer when it's closed adequately on the plate. We don't want to squeeze it too hard. We want to, just close it good enough so that we can grip it properly. Okay. And then we declare the servo 32U4, and we're just going to call it jaw servo, and just set the timer. I'm just going to call it print timer, and set that to a delay of 500 milliseconds. So this is kind of nice. You can check this timer, and I'll just show you that down here a little bit. Right, if print timer is expired, so whenever you check it, if it's past 500 milliseconds, when you check it, that says true. So then, if that's true, then we're going to print, and then that automatically resets the timer again, so it gets it going again when you check it. If you check it and it hasn't expired, it's less than 500 milliseconds since the last time you check it, then it will just read false. Okay, so you can see that I'm just going to start out by using this jaw servo, and again, you write in microseconds. You're going to give it that kind of pulse, and the servo stop. Again, I just had that set to 1490, and that might be a little bit bigger or a little bit smaller depending on how you can actually adjust this right on the servo as well. But anyways, so it gets the reading, prints out the initial voltage in ADC, so we'll see what that number is. And then while the button is pressed, we'll start out by moving the jaw down. And so while the linear potentiometer is bigger than the value for the jaw is open, it just continues down. And then again, it's checking the timer here. It's keeps reading the current value on the linear potentiometer and checking that, and every 500 milliseconds it prints out the value. And once it gets open to a certain position, then it stops, and we're just seeing how much drift there is here. So in other words, I'm printing out and then just delaying 5 seconds, printing out that voltage again, see how much it's changed, and then we're going to move the draw up. So we have right microseconds and the value that we have for the speed that we want it to close. And then we're checking while our voltage is less than the voltage. The way mine was set up, the voltage is higher when it's closed. So then once you get to the destination, then you're just going to stop it, and you can see it just print out a couple of times to see if there's any drift, and then just stop. Okay, so this stop servo. This one executes whenever if we release the button, it's going to finish this loop that's inside the while loop, and then it's going to check again to see if the button's pressed, and at that point, if the button isn't pressed, then it will stop also. Okay, so we'll go ahead and run this code. Okay, just going to turn this on. Okay, so we'll just go ahead. Okay, and then I'll go ahead and download it. Okay, and so you can see that it's starting out, it's already closed, right? So, oops, let me see if I can show this. And you can see it's kind of ticking a little bit. It's not quite at 0. So let me go ahead now. I'll hold down the button. And so now you can see that the drawer is starting to open. Again, I don't have it going super fast, and you can see that the ADC readout is dropping, and so should stop at 600. You can see it's before the delay, and you can see it's a little bit of drift. And now it's going to start closing again. Okay, and I'm just going to get ready here with the plate. Okay, and so now it's holding the plate, and you can see it's got a good grip on the plate, and it's going to wait a few seconds and then start to open back up again. Right. Oh, I have my hand on here, so I have to hold the button down again because it's back at the top, and we have to get it going again. There we go. Okay. And I release the button. Okay. So I think what happened there. So anyways, so that's opened back up. If I wanted to open it even more, then I would just set the voltage destination to be something less. So okay, you can see again, stop now, but the potentiometer doesn't have like isn't it is there's a little bit of slop where the lever goes into the jaw. So if I was going to print this for the project, I'd probably print that up a little tighter or put a little piece of tape around it so there wasn't any slop. But you can see I had it the jar open is 600, so that's around 600. If you wanted it to open up wider, then you could just lower that number, right? So for my particular gripper 940, it grips it at that point. It's not gripping it too hard, but it's gripping it so it doesn't slip at 940, and then you can open it, wide. If you want to open it wider, you just make that, maybe you might make that 400 or something like that. So, anyways, just let me know if you have any questions.